This video will be about intramolecular bonds. And if you don't know what an intramolecular bond is, let's take water for example. And we know water has hydrogens and oxygen, two hydrogens and one oxygen. So the atoms within water, which are the hydrogens and the oxygen, are bonded to each other. And this is a kind of bond that is called intramolecular, which is the bond between the atoms in a molecule. So this is an intramolecular bond, and that's an intramolecular bond. So let's begin with ionic bonds. Now ionic bonds are bonds between ions, and ions are atoms with a charge. Let's use potassium chloride. Potassium has one valence electron, chlorine has 7. These are the atoms in their neutral states. So when they come to bond together, we got to think about electronegativity. And electronegativity is the desire for an atom for electrons. So we can also think of it as somewhat of a tug of war. So electronegativity, you can think of it as kind of like the strength also. So if chlorine has a higher electronegativity, it will really want those electrons compared to potassium. Now what happens in a tug of war when you have one person who really wants to pull the rope way more than the other? Well, of course, this will not be in the middle anymore. It will be over here. That the rope will be pulled over here really easily because he really wants it more. He has more strength. So electronegativity can be thought like that. The chlorine has higher electronegativity compared to potassium. So that means it will really want the electrons way more. So when they come to bond together, what happens is when they meet, the chlorine will say, "Hey, potassium, I really want your electrons. I really want them." And potassium doesn't really want them as much. So it'll say, "Okay, here you go. You can have my electron." And they're both happy. They'll be bonded together now. So now that potassium gave up its electron, it lost the negative charge, so has a +1 formal charge. Now chlorine here, it gained a negative charge, so it has a -1 formal charge, and that's an ionic bond. Now for covalent bonds, there are two types, nonpolar and polar. Now for an example, I'll use methane for nonpolar, and for polar, I'll use hydrochloric acid. So for a nonpolar covalent bond, first of all, covalent bonds are not like ionic bonds because instead of one atom taking the electrons, the atoms, they will kind of share it. And so let's look at carbon and hydrogen. Well, in this methane molecule, carbon and hydrogen somewhat equally want the electrons. So they can't really tug on the electrons harder than the other. So what happens is the electrons will somewhat be in the middle, and it will not induce an ion because the negative charges are just stuck in the middle evenly between the two atoms. And that also makes it nonpolar because the charges are distributed evenly throughout the bond. Now for the polar molecule, we know that chlorine's electronegativity is pretty high, and hydrogen's does not even reach chlorine, not close. But hydrogen's electronegativity is higher than potassium, so it can still hold on to its electrons a little bit better than potassium, so it won't give it up. So what happens here is chlorine, when it comes to bond with hydrogen, it'll say, "Hey, give me your electrons." but hydrogen's gonna fight for it. But chlorine is much stronger, he has much more desire to hold on to those electrons, to grab onto them. But hydrogen just won't let go. So what happens here is they're still sharing the electrons, but they're a little bit closer to the side of chlorine. Now what happens here is that since there are more electrons to this side of the molecule, this side of the molecule will have a partial negative charge. And now hydrogen is somewhat missing an electron, so it has a partial positive charge. That's what makes this molecule of hydrochloric acid polar and covalent, because they're still sharing an electron, they're electrons in the bond, but the electrons are kind of skewed to one side where there can still be a difference in charge within the molecule.